Okay, class, today we want to cover the Chemistry Standard 6. We've been talking about concentrations, solutes, solvents, and the behavior of acids and bases. And so the objective for today is we're going to talk about the relationship between acids and bases and hydrogen ion concentration, and specifically how this relates to the pH scale and how to determine something as acidic, basic, or neutral on that pH scale. So, let's ask the question, what does the pH scale actually measure? And we know it measures the acidity or basicity of a solution, but what does that actually mean in terms of the physicality of that solution? And what it is an acidic solution is going to have a higher concentration of hydrogen ions than of hydronium ions. And in the reverse, a basic solution is going to have a higher concentration of hydroniums than the hydrogen ions. So, if we look at these two ions together, H plus and OH minus, we have a water molecule. So, in water, naturally, water is going to slightly disassociate, just a tiny amount at any given time in a pure water substance, is going to have a small amount of H plus and a small amount of OH minus floating around in the solution. So when we add different other different solutes into that solution, we can encourage the creation of these hydrogen ions or the creation of these OH plus ions. So the important thing to remember, though, is that an acidic solution is going to have a higher H plus than OH ions, and a basic solution is going to have a higher OH than an H plus ions. But the neutral solution is going to have equal amounts of both, and that's why water, which is H2O, is going to have a 7 on a pH scale as a neutral solution. So what is 7 on the pH scale? 7 is the equal amounts of hydrogen and hydronium. So this is our concentration of H plus and this is our concentration of OH minus in actual numbers. These are how many of these little guys I have in my solution. And so when I have a high concentration of H plus, I'm going to have a pH of 14, okay? And this is an acidic solution. So the higher my concentration of pH, the lower the amount of OH minus I have, and vice versa. So the cool thing about this scale is that it is inversely related, as in we always are going to have the concentrations equal the same number because these concentrations came from the dissociation of water. So if I have a high pH, let's say 12, and I add it to my pOH, which is the same as pH, only instead of measuring hydrogen, we're measuring the OH, or the OH minus ion. So when I add them together, I'm going to get 14. Now I know this kind of looks kind of confusing, but the important thing to remember here is that the pOH and the OH added together is always going to equal 14 on the pH scale. So let's go ahead and take a little bit more in-depth look. If you watch this video, it should help you understand that more. It is a confusing topic, so don't feel bad if you still need some help with it. Here at Science Buddies, it's going to explain it in a little bit different way and might help you get it. Just kind of go over it a couple times. Here are my references, and this was my video, and thank you for watching.